Welcome to Brain Vision.
So here we are told that when t is equaling 4 times the period, this would be for part A. When t equals 4 times the period, we can say that t is equaling 2 pi divided by omega prime, and this would be equal to 2 pi multiplied by the square root of the mass divided by the spring constant. This is given to us. We can then say that the damping factor would be equaling e to the negative b, the damping constant, times t divided by 2m. We know this to be equal to 3 over 4. Therefore, t is going to be equal to 2 pi multiplied by the mass of 2.00 kilograms divided by the spring constant of 10.0 newtons per meter, and we find the period equal to be 2.81 seconds. So essentially, we find that after applying the natural log to both sides of this equation here, we find that the damping constant times 4t divided by 2 times the mass would be equal to the natural log of 4 over 3. And this is going to be equal to 0.288. Therefore, B, the damping constant, is 2 times 2.00 kilograms multiplied by 0.288, and this would be divided by 4 times the period of 2.81 seconds. We find the damping constant for part A to be 0.102 kilograms per second. This would be our final answer for part A. For part B, we know that initially the energy is going to be equal to the maximum kinetic energy, 1/2 times the spring constant times the amplitude squared. This is going to be equal to 1/2 times 10.0 newtons per meter multiplied by 0.250 meters quantity squared. This is equaling 0.313 joules. So at t equaling 4 times the period, we find that the energy is going to be equal to 1/2 times k multiplied by 3/4 times x sub mo squared. This is going to be equal to 1/2 times 10.0 multiplied by 3/4 times 0.250 quantity squared. And the energy at t equals 4 times the period is equaling 0.176 joules. Therefore, we can say that the change in energy would be equal to the original minus the final at t equals 4t, and this is equaling 0.313 minus 0.176, 0.137 joules. This would be equal to the change in energy after 4 cycles. That is the end of the solution. Thank you for watching.